Afternoon. My name is V. Pradeep Reddy and my roll number is 2095182151 and I am from Aeronautical Engineering branch and my subject high speed aerodynamics concept video topic is third law of thermodynamics. Introduction. The third law of thermodynamics states regarding the properties of closed systems in thermodynamic equilibrium. The entropy of a system approaches a constant value when its temperature approaches absolute zero. This constant value cannot depend on any other parameters characterizing the closed systems, such as pressure or applied magnetic field. At absolute zero, that is 0 Kelvin, the system must be in a state with the minimum possible energy. Entropy is related to the number of accessible microstates, and there is typically one unique state called the ground state with minimum energy. In such a case, the entropy at absolute zero will be exactly zero. Residual entropy. If the system does not have a well defined order, if its order is glassy, for example, then there may remain some finite entropy as the system is brought to very low temperatures, either because the system becomes locked into a configuration with non minimal energy or because the minimum energy state is non unique. The constant value is called the residual entropy of the system. The entropy is essentially a state function, meaning the inherent value of different atoms, molecules, and other configurations of particles, including subatomic or atomic particle material, is defined by entropy, which can be discovered near 0 Kelvin. The Nernst-Simon statement of the third law of thermodynamics concerns thermodynamic process at a fixed low temperature. The entropy change associated with any condensed system undergoing a reversible isothermal process approaches zero as the temperature at which it is performed approaches 0 Kelvin. Here, a condensed system refers to liquids and solids. A classical formulation by Nernst, actually a consequence of the third law, is it is impossible for any process, no matter how idealized, to reduce the entropy of a system so its absolute zero value in a finite number of operations. There also exists a formulation of third law which approaches the subject by postulating a specific energy behavior. If the composite of two thermodynamic systems constitutes an isolated system, then any energy exchange in any form between these two systems is bounded. Explanation. In simple terms, the third law states that the entropy of a perfect crystal of a pure substance approaches zero as the temperature approaches zero. The alignment of a perfect crystal leaves no ambiguity as to the location and orientation of each part of the crystal. As the energy of the crystal is reduced, the vibrations of the individual atoms are reduced to nothing, and the crystal becomes the same everywhere. The third law provides an absolute reference point for the determination of entropy at any other temperature. The entropy of a closed system, determined relative to the zero point, is then the absolute entropy of that system. Mathematically, the absolute entropy of any system at zero Temperature is the natural log of the number of ground states times the Boltzmann constant. Kb equals to 1.38 into 10 power minus 23 joule per Kelvin. Consequences. Absolute zero. The third law is equivalent to the statement that it is impossibly by any procedure, no matter how idealized, to reduce the temperature of any closed system to zero temperature in a finite number of finite operations. The reason that t equals to 0 cannot be reached according to the third law is explained as follows. Suppose that the temperature of a substance can be reduced in an isentropic process by changing the parameter x from x2 to x1. One can think of a multi-stage nuclear demagnetization setup where a magnetic field is switched on and off in a controlled way. If there were any entropy difference at absolute 0, t equal to 0 could be reached in a finite number of steps. However, at t equal to 0, there is no entropy difference. So, an infinite number of steps would be indeed needed. At zero temperature, the system must be in a state with the minimum thermal energy. Mathematically, the absolute entropy of any system at zero temperature is the natural log of the number of ground states times the Boltzmann constant Kb. For the entropy at absolute zero to be zero, the magnetic moments of a particularly ordered crystal must themselves be perfectly ordered. The third law of thermodynamics states that the entropy of a system approaches a constant value as the temperature approaches absolute zero. The entropy of a system at absolute zero is typically zero, and in all cases is determined only by the number of different ground states it has. Specifically, the entropy of a pure crystalline substance at absolute zero temperature is zero. This statement holds true if the perfect crystal has only one state with minimum energy. As you can see, the difference between Kelvin, Celsius and Fahrenheit scales. In Kelvin, water boils at 373 Kelvin and Celsius 100 degrees Celsius, and in Fahrenheit 212 degrees Fahrenheit. Water freezes at 273 Kelvin, 0 degrees Celsius and 32 degrees Fahrenheit. And the absolute zero is situated in 0 Kelvin minus 273 degrees Celsius and minus 459 degrees Fahrenheit. Third law of thermodynamics, decrease in temperature. As you can see, decrease in kinetic energy. More decrease in temperature tends to more decrease in kinetic energy. 0 Kelvin or minus 273.15 degrees Celsius is nothing but zero entropy. That is, there is zero kinetic energy. Means there is no movement of the particles, molecules. The third law of thermodynamics statements the value of entropy of a completely pure crystalline substance is zero at absolute zero temperature. 0 Kelvin is absolute zero temperature. So, the third law thermodynamics statement the value of entropy of a completely pure crystalline substance is zero at absolute zero temperature. As you can see in the first figure, the molecules have a little bit movement. In the second figure, the molecules are almost have zero movement, and in the third figure, the molecules are at completely rest. That is no kinetic energy. Thank you.